my name is Louise Daly, and in this presentation, I'll be exploring how artificial intelligence and blockchain technologies are working together to reshape wireless communication. As wireless networks continue to evolve, these two technologies are playing a critical role, not only in improving speed and efficiency, but also in enabling more secure, intelligent, and decentralized systems. We're entering an era where networks aren't just fast, they're adaptive, autonomous, and built on trust. This presentation focuses on how that's happening and why it matters. I've organized this presentation into three main parts. First, I'll begin with the foundations, briefly explaining how exactly blockchain works and how it fits into the architecture of modern wireless networks. Then I'll move into integration, where I'll show how AI and blockchain interact across different layers of the network, from the cloud to the edge, to enable real-time optimization and control. And finally, I'll highlight key applications, including how these technologies are being used to enhance security, automate processes, and support emerging systems like smart cities and autonomous vehicles. By the end, you'll have a clear understanding of how AI and blockchain are working together to transform the way wireless networks operate. So to understand how blockchain fits into wireless communication, we first need to look at how the structure works. Blockchain is essentially a decentralized digital ledger. Each entry or block stores data about a transaction or an event, along with a timestamp, which is a reference to the previous block, and a unique identifier called a block hash. These elements ensure that every block is connected in order and cannot be changed without altering the entire chain. New blocks are created by verified miners who follow consensus rules to validate data and add it to the network. The structure also supports smart contracts, which are automated code that can execute actions when certain conditions are met. In wireless networks, this level of transparency, trust, and verifiability is essential. It helps manage device identities, secure transmissions, and maintain an auditable record of communication without relying on any central authority. And as wireless networks become more complex and more distributed, security and privacy are becoming harder to manage, and more important than ever. In 6G environments, where everything from autonomous vehicles to healthcare devices and smart city infrastructure is constantly communicating, there's no single central system managing all of that data. That's where blockchain comes in. Because blockchain is decentralized and tamper-resistant, it offers a built-in way for secure communication across these networks. It ensures that data is verified before it's accepted and that its identities are authenticated without relying on central authority. And in this diagram, you can see how blockchain supports diverse parts of the 6G ecosystem, from end-user devices to edge computing and core systems, while providing consistent layers of trust and validation. By using blockchain to handle access control, data integrity, and identity protection, 6G networks can become more resilient, more transparent, and less vulnerable to attacks. One of the biggest challenges in optimizing wireless communication is figuring out where data should be processed. Not everything can or should be sent to the cloud, especially when speed and local decision-making can be critical. That's where a hybrid cloud fog edge architecture comes in. This layered approach distributes computing power across the network, from the cloud at the top to regional fog nodes, and finally down to edge devices like sensors, vehicles, or phones. In this diagram, you can see how blockchain and AI operate across these layers. For example, smart contracts can be deployed at the fog or edge level to automate decisions close to where data is generated. Meanwhile, the cloud provides a high-level view for managing policies, analytics, and long-term storage. This kind of decentralized structure is ideal for wireless environments because it reduces latency, improves scalability, and allows AI models to respond in real time without sacrificing security or the necessary trust. By integrating blockchain and AI into this architecture, wireless networks can become more intelligent, adaptive, and efficient from end to end. Now that we've explored how AI and blockchain technologies are being integrated into wireless infrastructure, let's shift our focus to how they're being applied in real-world systems. This diagram highlights just how versatile blockchain can be across wireless networks. It's not just about securing data. It's also about enabling smarter communication, managing resources, and protecting privacy in complex decentralized environments. AI plays a key role here by optimizing how and when blockchain services are used, whether it's selecting the most efficient communication path, managing bandwidth allocation, or predicting network congestion before it happens. One major application is device-to-device communication, where blockchain verifies identities and makes sure data is exchanged securely without relying on a central server. In large systems, blockchain supports spectrum trading, where available bandwidth can be shared, allocated, or reassigned dynamically between users or service providers. It's also used for service continuity, helping users stay connected as they move across different network zones, all while maintaining seamless access and security. So whether it's authenticating users, managing access, or coordinating how resources are shared, blockchain combined with AI provides a reliable foundation for trusted, decentralized network communication. And in this example, we'll see how AI and blockchain technologies are being applied together to improve control and coordination across fiber wireless access networks. These type of networks are becoming more common as we push for higher speeds and greater connectivity. But managing the flow of information between wired and wireless components, especially in real time, is extremely complex. AI helps by monitoring performance, analyzing traffic patterns, and dynamically adjusting how resources are allocated. It ensures the network services are delivered efficiently, even as the conditions may change. And at the same time, blockchain provides a secure and decentralized way to coordinate actions across devices. It ensures that only authorized nodes can make changes and that all actions are transparent and traceable. Together, AI and blockchain allow these hybrid networks to make intelligent decisions on the fly, while maintaining trust, accountability, and security across both wired and the wireless layers. The final application I'd like to look at is something called BRAN, or Blockchain Radio Access Networks. In traditional wireless systems, control is often centralized, which can lead to bottlenecks, slower responsiveness, and security challenges. BRAN offers a different approach, using a decentralized blockchain-based architecture to allow parts of the network to operate more independently while still working in sync. AI enhances the setup by monitoring local network conditions and making fast decisions, like when to hand off a connection, how to balance traffic, or how to manage user mobility. At the same time, blockchain adds a layer of transparency and trust, recording each interaction so that the network remains secure and accountable without needing a central authority. BRAN is especially useful in high-demand environments like autonomous vehicles, smart factories, or emergency response systems, where secure, real-time decisions are critical. So together, AI and blockchain are turning the radio access layer into a space that's more adaptive, resilient, and intelligent. In conclusion, wireless networks are no longer just about moving data quickly. They're evolving into intelligent ecosystems that can sense, decide, and adapt on their own. Blockchain gives these systems a foundation of trust. It secures communication, protects identities, and ensures transparency without relying on any central authority. AI brings the intelligence layer, analyzing traffic patterns, predicting demand, and optimizing performance while making real-time decisions. When you bring these two technologies together, you get more than just efficiency. You get wireless networks that are decentralized, resilient, and built to support the future. From smart cities and autonomous systems to global data markets and next-generation infrastructure. As this graphic shows, the benefits are broad, but the core idea is simple. AI and blockchain are enabling networks that don't just work, they think, they learn, and they earn our trust. To me, this is more than just innovation. It's the beginning of a new era in network communication. Thank you.